Ashley and I have been working on a device that attenuates the magnitude of vibration it experiences in response to resting tremors. Resting tremors is one of 4 cardinal symptoms of Parkinson's disease, which affects around 4 million globally, and 70% of those experience the tremors. I will further highlight the incidence of another significant tremor syndrome, such that the device is not solely marketed as an assistive device for Parkinson's. Around 5% of the senior population experiences essential tremor, which adds around 30 million to the number of people that experience tremors. Currently marketed devices for Parkinson's largely address postural instability. However, there are also everyday items like pens and coffee mugs that have been given broadened handles to ease the need for dexterous control. There are various mechatronic solutions under research, such as a wearable wrist brace that counteracts tremor magnitude or spoons that level themselves. With that, we wish to leverage these kinds of mechatronics in order to address the need for drinking fluids. We propose that an actively controlled coffee mug will suppress resting tremors to effectively reduce spilling in amount and frequency compared to a passive coffee mug design.
When motion is introduced to the handle of a passive coffee cup, spilling occurs frequently and in large amounts, as we can see here. We sought out to prototype an actively controlled mug that can correct for motion in 2 degrees of freedom. A signal is sent from a gyroscope sensor located at the bottom of the liquid containment to the microcontroller driving the servo motors to correct for motion felt in the handle of the mug. We wanted to create a mug that would be envisioned as discrete, and as you can see here, our prototype hides all electronic components. The cup is activated with a push button located on the handle for convenience, which can be seen in picture A. After the mug is turned on, the gyroscope sensor collects data of the cup's position. The goal is to keep the liquid inside the mug stable, and therefore feedback is sent to the servo motors controlling the motion along the y-axis as seen in picture B and the x-axis as seen in picture C. When the user would like to take a drink, the cup is lifted to the user's mouth and the tilt along the y-axis is saturated at 15 degrees, preventing further rotation. You can see this in picture D. And now we'd like to show you our prototype in action. Looking to the future, we'd like to make some changes. While our prototype can display the motion of stabilization, it is not as smooth as we would like it to be. In future iterations, higher quality components would be used. The servo motors are loud, and using brushless motors instead would cut down on this noise. We would like to think about making sure that all components are sealed and properly insulated from hot liquids. The next step would be to conduct human subject testing to ensure that the product works correctly and whether it would be useful for the target audience. Thank you. Does anybody have any questions?